Hey everyone, welcome back. Today we are going to explore some Python functions that every pro uses. These are the functions that can make your code cleaner, faster, and much more efficient, helping you go from beginner to pro. So, if you want to level up your Python skills and write smarter, more professional code, stick around till the end. Let's talk about a very handy function called enumerate. This function is super useful whenever you want to loop through a list and get the position number and the value at the same time. When beginners want both the position and the value, they usually write something like this. First, we are getting the size of the list. Then we loop over a range of numbers from 0 up to that size. Inside the loop, we are using the number to pick out the item from the list. Yes, it works. It gives the result we want, but the problem is this looks messy. You are doing too many things. Checking the size, creating numbers one by one, and then using those numbers to get the actual fruit. It's like going in circles. For small programs, it may not feel like a big issue, but as your code grows, this style becomes harder to read. If someone else looks at your code, they have to pause and think what is happening here. Another issue is mistakes with numbers. If you accidentally change something, you can run into errors where the index does not match the item. So, while this method is common, it is not the cleanest way to write loops. Now, let's look at the professional way. Python gives us a built-in function called enumerate that makes all of this simple. Enumerate automatically gives you two things on each loop: the position number and the actual value. You don't need to calculate the size of the list, you don't need to create numbers, and you don't need to use those numbers to pick items. This loop directly tells Python that hey, I want both the position and the fruit at the same time, and Python takes care of the rest. And this is all about the enumerate. It does the same thing but in a way that is short, clear, and very easy to read. So the output is exactly the same. But the second one looks cleaner and feels professional. Now that we have seen how enumerate cleans up our loops when we are working with the single list, let's talk about the next step. Sometimes instead of one list, you want to work with two lists together. For example, imagine you have a list of student names and a list of their marks. Beginners usually try to solve this with indexes again, and it quickly becomes messy. But don't worry, Python has another smart function to handle this exact situation. It's called zip, and it lets you loop through two lists side by side without doing any extra work. This function is made for the situations where we want to loop through two lists at the same time. Suppose we have two lists and we want to print each name with its score, means Motu with 85. Most beginners will write something like this. Yes, this works, but look at the problems here. We are looping using numbers. We have to pick out values from both lists separately. If the lists have different lengths, this can easily give errors. The code is not very clear. Someone reading it has to stop and think about what's happening. But Python makes this very simple with zip. That's it. With zip, Python automatically pairs the first item of each list, then the second items, then the third, and so on. This way you directly get the name and the score together in the loop without writing extra code. Beginner code works but looks longer and harder to read. But the pro code looks clean, simple, and readable. So the output is the same, but the second method looks professional and avoids mistakes. Now that we have seen how zip makes it easy to combine two lists, let's think about the next step. When we have data, whether it's a single list or even pairs of values from two lists, we often want to arrange it in order. For example, sorting numbers from smallest to largest, or arranging names alphabetically. That's where the sorted function comes in, and it gives us a very flexible way to organize our data. This function helps us arrange items in order, from smallest to largest or largest to smallest. Suppose we have a list of numbers. The beginner will use the sort function. This works. The list becomes 1, 2, 5, 7, 9. But here's the problem. The sort method changes the original list. So, if you still need the original list later, it's already lost. Beginners often face this issue and get confused why their list looks different afterwards. So, instead of changing the original list, we can use sorted. Here, sorted creates a new list that is arranged in order, while keeping the original list untouched. We can also sort in descending order very easily just by adding reverse equals to true. Now, let's look at the real power of sorted. It has a special option called key, which lets us decide how the sorting should happen. By default, Python sorts numbers normally and strings alphabetically. But what if we want to sort a list of more complex items like pairs? Let's see an example. If we just write sorted students, Python will sort by the first item in each pair, which means it will arrange them alphabetically by name. Now, let's look at the real power of sorted. It has a special option called key, which lets us decide how the sorting should happen. By default, Python sorts numbers normally and strings alphabetically. But what if we want to sort a list of more complex items like pairs? If we just write sorted students, Python will sort by the first item in each pair, which means it will arrange them alphabetically by name. But what if we want to sort by score instead? That's where the key option comes in. We can tell Python to use the score, that is the second value in each pair, for sorting. Here's what happens. Python looks at each student. It calls our function getScore to decide the sorting value. Since getScore returns the score, the list is sorted by scores. You can see in the output. So, in simple words, the key is just a rule that tells Python what part of each item it should look when arranging them. So, sorted is not about just arranging numbers. It can also handle complex data and lets us decide exactly how things should be sorted. Now, once we understand sorting, the next step is creating small, quick functions that we can use inside operations like this without writing a full function every time. That's where lambda functions come in. These are also called anonymous functions, which means they don't need a name. They are mainly used when we want to create small, quick functions without writing a full function block. Suppose we want to double a number. A beginner usually write like this. This works perfectly, but the problem is, for such a small operation, writing a full function feels like too much. We have to write def, give the function a name, write the return statement, all just to multiply by 2. So, with lambda, we can write the same logic in just one line. Lambda x means we are writing a function that takes x as input. X into 2 is what the function returns, and we assign it to the name double. So, this is exactly the same as the earlier function, but much shorter. The real power of lambda shows up when we use it inside other functions like sorted, map, or filter. For example, imagine we have a list of students. If we want to sort them by score, we could write a separate function, like we did earlier. But with lambda, it becomes one line. Here, the lambda quickly tells Python, when sorting, look at the score, that is the second value. No need to write a separate function. Beginner's code works fine but feels too heavy for small tasks. But lambda makes it much shorter cleaner, and perfect for quick operations. So, lambda helps us keep our code short and powerful by avoiding unnecessary functions. And now that we know how to write small quick functions, the next step is to see how we can apply those functions to an entire list at once. That's where the map function comes in. This lets us apply a function to every item in a list automatically. Suppose we have a list of numbers and we want to double each number. A beginner usually writes something like this. This works fine, but notice the extra steps. We had to create an empty list first, then we had to loop through each number, do the calculation and append it. The code looks longer for such a simple task. The map function cleans this up. It applies a given function to each item in the list automatically. Map takes two things, a function and a list. The function here is returning the double of the x. It applies that function to every number in the list. Finally, we've wrapped it with the list to see the result as a list. So, instead of writing loops and appending, we got everything in just one line. Here is another example of map. Imagine we have a list of names and we want to convert them all to uppercase. Here, we didn't even use lambda. We directly pass the function str.upper. That's how flexible map is. Basically, beginner use loops, create new lists, keep appending. That looks heavy. But pro users map. Short, clean and handles everything for you. So, map is great when we want to transform or change every item in a list. Now, let's jump to the another function, filter. We just saw that how map applies a function to every item in a list and transforms it. But sometimes instead of transforming items, we only want to select specific items that meet a condition. That's where the filter function comes in. Suppose we have a list of numbers and we only want the even numbers. A beginner usually writes like this. This works fine, but again, we had to write a loop, an if condition and keep appending values manually. But the filter function makes this very short and clean. Filter takes two things, a function and a list. The function checks whether an item should be kept or ignored. We use lambda function to keep the number if it's divisible by 2. Then wrapping with list shows the filtered result as a list. So, instead of writing a full loop with conditions, one line does the job. Let's see another example. Suppose we have a list of names and we only want names longer than 3 letters. We can write it like this using filter, which is clean, simple and directly tells Python what to keep. So, filter helps us narrow down a list to only the items we actually want. But sometimes we don't just want to pick or transform items. Instead, we want to check conditions across the whole list. For example, is there at least one item that matches a condition? Or do all items match a condition? That's where any and all come into play. Suppose we have a list of numbers and we want to know if at least one number is even. We usually write the code like this. This works, but notice how we had to use a loop, a condition and even a break statement. Here, the any function can make this super short. This condition checks if each number is even. The expression inside parentheses runs for all numbers. Any returns true if at least one of them is true. So, just one line replaces the whole loop. So, what about all? Now, suppose we want to check if all numbers are positive. A beginner will write code like this. But the pro will use all function. This condition checks each number. all returns true only if every single check is true. If even one number fails the condition, it returns false. So, any and all are perfect when we want to quickly check if some or all items meet a condition. But sometimes, instead of checking conditions, we just want to directly find the smallest or largest value in a collection. That's where the min and max function come in. Suppose we have a list of numbers and we want the smallest number. We can directly use this function like this. Normally, we use loops for finding the minimum value, but one simple function can replace the whole loop. So, what about max? It also works similar, but to find the largest number. That's it. Clean, short and instantly gives us the answer. Just like sorted, both min and max also support the key parameter. This lets us decide how the comparison is done. For example, suppose we want the longest word in a list. Here, key equal to length tells Python that don't compare words alphabetically, compare their length instead. So, it returns the banana, the longest word. So, min and max are great when we want to directly find the smallest or largest value. But sometimes, instead of working with values, we want to explore what functions and attributes are available for a Python object. That's where the dir function is super helpful. Imagine you are working with a string and wants to know what operations are available. Then you usually search on Google like what can I do with Python strings. Or you will try random things like text.upper, text.append. The trial and error method is frustrating and beginners often waste time guessing this. With dir, we can directly ask Python what an object can do. Like, this prints a list of all the methods and attributes that strings support, like upper, lower, replace and many more. Now, instead of guessing, you can just look at the list and use what we need. Let's try it on a list. Here, we will see methods like append, extend, pop, sort, etc. So, dir works on any object. Whether it's a string, list, dictionary, or even custom object. Beginners search online or randomly try methods, often hitting errors. But the pro use dir to instantly discover what's available. So, dir helps us explore objects and discover their capabilities. But sometimes, instead of just exploring, we actually want Python to execute code that comes in as a string. That's exactly what the eval function does. Suppose we take input from a user and want to calculate something. Beginner manually thinks, okay, how can I solve this? They might split strings, convert numbers and write their own logic. This becomes unnecessarily complex because they try to build a calculator themselves just to evaluate a simple math expression. But with eval, Python itself can evaluate the string as a code. Eval takes the string and runs it as a Python expression. So, 2 plus 3 into 4 is treated the same way as if we type 2 plus 3 into 4 directly. We can even use variables inside eval. Here, Python understood that x and y are variables and used their values in the calculation. While eval is powerful, it can also be dangerous if used with untrusted input, because it can execute any code. So, in real-world projects, use it carefully and only when you trust the source of the string. We have covered a lot of Python functions so far, from zip and sorted to lambda, map and filter. Now, here's a bonus function that many beginners don't notice but is super powerful. Reduce. The reduce function is used when you want to combine all items in a list into a single result. For example, you might want to multiply all numbers together. or sum all numbers, or apply any operation that reduce a list to a single value. Suppose we have a list of numbers and we want to find their product. With reduce, we can do this in just one line. Reduce takes a function and a list. The function takes two values at a time and combines them. Lambda function tells Python how to combine them. Multiply in this case. Reduce keeps applying this function until only one value is left, the final result. So, why reduce is useful? Because reduce combines list into a single value in one line. And it is great for calculations like sum, product or custom combinations. And it works well with lambda for quick and inline functions. And that's it for today's video. We have looked at some powerful Python functions that every pro uses to make coding simpler and more efficient. If you found this video helpful, don't forget to like, comment and subscribe. Tell me in the comments which of these functions you are going to start using in your own projects. Thanks for watching and I will see you in the next video.